7.3, Introduction to Probability. We start off with a few definitions. Experiment is an activity or occurrence with an observable result. A trial is each repetition of that experiment. Outcomes are the possible results of each trial, and sample space is the set of all possible outcomes for an experiment. Number 1 says, give the sample space for each experiment. Part A, a spinner like this one is spun. Okay, so sometimes students struggle with sample space, but sample space is just what is possible. Okay, we're making a set, and we're going to list out everything that's possible. So it's really not that hard. S equals, we're going to have a set. And so just visualize yourself flicking that little arrow and spinning that spinner. What are the possible outcomes? Well, you're either going to get a 1 or a 2 or a 3. That's the sample space. That's all there is to that. Part B says students are classified as in grade 9, 10, 11, or 12, and also as male or female. So let's think about that one. A little bit harder. Sample space. Okay, think about what you could have. You could have a pen that doesn't work. You could have a 9th grade male or 9th grade female. 10th grade male, 10th grade female. 11th grade male, 11th grade female, 12th grade male, 12th grade female. That would be the sample space for this. That's what's possible. Okay, now we're going to end up having to talk about how many things there are, how many items in the set. Okay, so how many elements are there in that set, in that sample space? Do you see 8? Okay, that's going to be an important number at some point. Part C, we're doing the same thing, sample space. The number of boys in families with exactly 3 children. I think this one's kind of weird, but if you have 3 children, how many of those children might be boys? Okay, 3, that's, or 2, or 0. Okay, right? Usually I'll write them in increasing order, but I suppose it doesn't really matter. All right, so the number of elements in that sample space is 4, of course. And then part D, the vowels in the English language are A, E, I, O, U. I'm not counting Y. I see 5 elements in that set of vowels. So when we talk about probability, we start talking about events. An event is just a subset of a sample space. So remember that symbol. An event is a subset of a sample space. Okay? Remember that symbol for subset? A simple event is an event with only one outcome. A certain event is an event that equals the sample space S. So if you think about it, a certain event is certain to happen, and the probability of that is 1. There's a 100% chance that it happens. It's a certain event. Probability equals 1. It's an event that equals the sample space. An impossible event is an event that equals the empty set. Okay? And so what do you think the probability of an impossible event is? 0. That is correct. Mutually exclusive events that cannot occur at the same time. So remember, we have this symbology for mutually exclusive, or in a previous lesson, we talked about disjoint sets. Disjoint sets. You got set E, you got set F inside some universe, and they don't overlap. There is no overlap. They are disjoint. The 2 events are mutually exclusive. Number 2, write each set. Part A, an experiment is an ordinary 6-sided die is rolled. So you've all played board games with a 6-sided die before. The sample space is just what is possible. So what is possible on my 6-sided die? 1, 2, 3, 4, 5, 6. That is the sample space, and the sample space lists out all of the possible outcomes. Now we've got event E. The die shows an even number. So this is a subset of the sample space. The die shows an even number, so I'm just talking about 2, 4, or 6. Event G, the die shows a number greater than 5. So what's greater than 5? Just 6, right? Just 6. That looks like a G. That's a 6. Okay, those are some events. Next one. Part B gives you the sample space. BBB, BBG, and so on and so on. H is an event, specifically that the family has exactly 2 girls. So fine, this is supposed to be boy, 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 girl. I took it out of a problem where they were talking about how many if a family had 3 children, how many were boys and how many were girls. So exactly 2 girls looks like this one or this one or this one, right? So that event H is going to be BGG, GBG, GGB. K, the 3 children are the same sex. So 3 boys or 3 girls, that's event K, right? B, 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 G, G, G. J, the family has 3 girls. Well, that's just this one, right? G, G, G. So we're talking about events. These events, H, K, and J, are subsets of the sample space. So, remember, we're talking about this symbol right here. H is a subset of S. That's what I mean, subset. Number 3, a coin is flipped until both a head and a tail appear, or until the coin has been flipped 4 times, whichever comes first. The sample space is given below. All right, so read that again. A coin is flipped until both a head and a tail appear, or until the coin has been flipped 4 times, whichever comes first. So this would be like flip a heads then tails, or heads, heads, tails, heads, 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 tails, that kind of thing. That's what we're looking at with the sample space. Write each of the following events in set notation. Event E, the coin is flipped exactly 3 times. Exactly 3 times. We'll find the ones that flip exactly 3 times. This one and this one. So event E equals H, H, T, 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 H. Event F, the coin is flipped at least 3 times. So at least 3 means 3 or 4. So we're talking about any of those elements that have flipped 3 or 4 times. So hopefully I have enough room here. There's no way. Let's just do this. There we go. H, H, T, H, 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 T, H, 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 T, T, H, T, 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 H, T, 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 T. Event G, the coin is flipped at least 2 times. So at least 2 times. Well, if you look at it, isn't that going to be everything? Every single one of those things has been listed or has been flipped at least 2 times, right? So I'm going to list all of them, all 8 of the possibilities. Or is there an easier way? Can't I just say it equals the sample space? You could list them all out if you want to, but I don't want to. Lazy that way, I guess. So then H, the coin is flipped fewer than 2 times. Are any of them flipped fewer than 2 times? No. So I'm talking about the empty set, right? Nothing. Set operations for events. Okay, we've already seen these symbols. E and F is this symbol, E and F. We read this as or, E or F, or both. And then not E when E does not occur. So we've already seen those symbols. There they are again. Number 4, study of workers earning the minimum wage groups such workers into various categories, which can be interpreted as events when a worker is selected at random. Consider the following events. E stands for the worker is under 20. F, the worker is white. G, the worker is female. So we want to describe the following events in words. So this symbol right here, the complement of E, or not E, would represent, you look at this is E, right? So if it's not E, then what would we say? The worker is, I'm sorry? Over 20. What about if they're equal 20? How about 20 or older? It's not under 20, then they're 20 or older. Okay, so then that next one, I'd read it as F and not G. F and not G. So you look at the words, the worker is, what's F? Worker is white and not a female, right? So what's an easier way of saying that maybe? Male. Let's say worker is white male. Okay. That's probably the easiest way to say it. You could reword that other ways as well. E or G. That says or, right? E or G. So the worker is under 20 what? Under 20 and female. I think I heard the wrong word. Or female, right? And there's a little bit of a difference, but we've got to read that as the word or. So otherwise correct. Worker is under 20 or female.